X min is 0, X max is, I'm not 2 pi, pi over 2, sorry. Pi divided by 2. So you type that in, as soon as I hit enter, it's going to switch it to radian decimal. I check I am in radian mode, so that's good. What should we do for the y min and y max? Sometimes what I do is I look at the table and just set this on automatic. Sometimes you can get an idea of what values you're going to need by just using the table. Here I've just set the table incrementing from 0 to point 0.1, 0.2, 0.3, and it's plugging in various radian measure for the angle and giving me, so I'm seeing that it's, it goes up there about over 100. So let's make the range maybe 150 for starters, and look at a graph, see what that looks like. There it is. It's a little hard for you to see. Does it look like there's some value between 0 and pi over 2 where the area is the most? Right? Are you going from 0 to pi over 2 and for y min and y max 0 to 150? In radian mode, in radians, that would be about 1.05. But your calculator has a command that will automatically find the maximum point. So would you like to see that? As long as we're got this far. Okay. So the trace button right here in your calculator, right above it, it says calc. See that? Stands for calculate. So do the second function and press the trace key, and you'll get this menu. Second function and the trace key. Second function. Anytime you want to get one of these yellow commands above a key, use the second function key. So second function. You got that? Did you get it? Okay. And a right boundary, and then it wants you to guess, and then it'll find you the answer. So you want to move the trace here with the. You can either type a number in, but just use the trace. To the left, press enter, now it asks for a right bound, so you move to the right. Keep moving until you get to the past the point you're interested in. Press enter. So we got a left boundary and a right boundary. See these little marks? That means it's going to look between there. Now it wants a guess, so you can just move anywhere near it. And press enter to point. Okay, and then this x value is the data value that gives you the maximum, and this is the actual maximum area. Since we are still talking, we're talking about this at the end of today, and if you're going between 0 and 150, you're going to make a mark at every. Doesn't make sense to mark every one between 0 and 150. You might need to mark it every 25 or something like that. The resolution you leave whatever it is. Okay, here's the graph, and. So this is where we were yesterday. This problem you'll return to in calculus and you'll find the exact solution. You're just approximating the solution. Okay, so what do we do next? Let's use this as a review, because on the test on Monday I might have given you something like this. So how would you find the maximum point, and then we're going to interpret it. So what do you do? So you want to use this button because you want to do the calc. So you press that and that. And then go down to maximum. Okay, the screen comes back. It puts a moving cursor on the graph. You see it's blinking, and it's asking you, what do you want to use for a left bound? And remember, it's just looking for brackets. So So you need to give it something to the left of, we know what we're looking for, we can see that's what we're looking for. This is to the left, so that'll work, so I press enter. Put a little mark there. Now you want to press the right arrow, I'm just going to hold it down and it's going to move this over, and I want to just make sure it goes to the right of the point I'm actually interested in. And I'm going to press enter again. And that marks, so now I've got those two marks. So I'm basically trying to tell the calculator where to look for the answer. Right? And then it wants me to guess. I don't know why I need to do that too, but so what I usually do is just go back a little bit. And this is, I think, where we ended the class yesterday. So I just want to spend a little more time on this part. So it gives me the coordinates, the x coordinate and the y coordinate of this point. And keeping in mind that we're using x, but that's actually our value for theta. So we're finding that we have a maximum cross-section area, which is, remember, that's what we were trying to figure out. What angle would give us the biggest area? At, looks like it's 1.047 about. Degrees or radians is this? Radians. Now, they just wanted you to do this problem in radians, so we did. But if you were actually making the gutter, right, or you asked somebody to make it for you, you're not really going to tell them, make the angle 1.047 radians. You'd probably give it to them in degrees, right? So this is the answer the problem is asking for, but just to kind of have a feel for what that is, we might, in a minute, we'll convert that to degrees just for ourselves. What is this 129.9? What is that? What are the units, first of all?
It's the area over
Okay. Is it, so it's the cross-sectional area, right? It's if you cut it. It's the face. And what were the units in this problem? What 129.9 what? What?
centimeter? Are you talking about that?
Yeah, yeah. So this is area, so
Centimeter squared.
yeah, centimeters squared. So 129.9 square centimeters is the maximum. So the maximum cross-sectional area at this value is this. So that means if we build ourselves a gutter where we make this angle right here 1.047 radians, then we'll guarantee that the area of this is as big as it possibly can be. Okay, so the last thing is just to relate this. If I have this amount of radians, how do I figure out how many degrees about that would be? Remember the conversion formulas? So you either multiply by 180 over pi or pi over 180. You want to end up with degrees. It's the 180 over pi, right? So you take this and you multiply by 180 divided by pi, and it comes out to 59.988 degrees. Okay, now you want to try to guess what the actual exact answer would be? 60. Turns out to be 60. Nice round number. And I think one or two people guessed that earlier. So that's a pretty good answer. Before there were graphing calculators, wouldn't be able to get these. We wouldn't be able to use technology to get that maximum, and you'd have to rely on calculus.